Today, we'll be discussing the diagnosis of concussions using machine learning algorithms. Within the scope of our background research includes concussions, current methods of diagnosis, and machine learning algorithms.
So concussions are caused by forceful blows to the head, and you can get them in car accidents and sometimes head-to-head contact sports, such as football, which many high schools play in America. Now, there are 2 million cases annually and about 150 deaths from concussions every day.
According to researchers at the University of Technology, Vienna, about $96 billion a year in the US alone are spent on concussion treatment for social and medical expenses. On this, there are about 90% of concussions are left untreated and undiagnosed, so that $96 billion doesn't even include that. So the current methods for diagnosis include CT scans and MRI scans, which take pictures of the brain for doctors to view and determine if there's some sort of damage done to the brain. But these require special medical equipment that cost a lot of money to use and are only found in ICUs.
And furthermore, these are requiring a patient to be conscious in many different situations. And as you guys can see in the diagram showing CT scan, really it's going to be synonymous for the most part. There are going to be a lot of features which you're not going to be able to detect, especially medical physicians or volunteers looking at this data aren't going to be able to determine the effect of a concussion and be able to diagnose it. So now on machine learning. So machine learning is essentially finding trends in data. And so now within that, it is currently used in medical applications, however, not so much in concussions.
So it could be used as a value asset for concussions, but currently it is not. Now, on the right, you can see a small explanation of how an artificial neural network or an AI would work. It takes an input, it runs an equation, and once it completes the equation, it comes with an output. For our first solution, we'll be going over whole brain analysis.
So what whole brain analysis is it's an analyzation of the structures of the brain, not necessarily pictures, but specific connections between neurons and groups of neurons within the brain. It checks for any bruising that is a very good sign of concussion, and even just any inflammation or sort of movement within all of the neurons. And according to researchers at the University of Worcester, they were able to make a model of the most common NFL head injuries and were able to determine the most common places that damage was done to the brain to make it easier to identify.
And so actually the study which Ben just described is actually pictured on the right, and that is using the Worcester head injury model. And so now one example of whole brain analysis is DTI, or diffusion tensor imaging, and that's looking at the small microstructures occurring within the white matter of the brain. So now on the benefits of whole brain analysis. Well, to begin, according to research conducted by the University of Technology, Vienna, the amount of data available is increasing exponentially.
Now, with this exponential growth, we can also use a more variety of features. And with these features, we can find more ways to diagnose concussions. Now, for the limitations of the whole brain analysis, the variance in image also it makes it very difficult for the AI to always predict the correct diagnosis, because there are so many differences in a person's brain and also compared to the Worcester model. There are small little things, like everybody's brain is slightly bigger or smaller, that make it hard to determine.
According to the researchers at Chang'an University, the simulations that have been recorded of whole brain analysis aren't accurate because the images of concussions aren't representative of normal humans. So the accuracy that's been proven can't be relied upon for real human diagnosis. Also, the image data is bulky and requires companies to pay a lot of money for server storage just to have all the information. So next we'll be talking about direct observation techniques. So what direct observation is it analyzes all 5 senses. It is a little box that connects to your phone and analyzes vision, hearing, smell, taste, and touch. It sees how they may have been changed due to a possible concussion.
And so now research conducted by the Uniformed Services University particularly observed speech within individuals who they believe had concussions. And really, they were able to, just using an iPad, determine with great accuracy whether an individual had a concussion or not. So, one example of direct observation is pupil screen, which was actually looked at by the University of Washington. And so now within this, high schools are really wanting an online test which they can use inexpensively and quickly as well. And so furthermore, all these direct observations can be imaged easily or recorded easily using mobile tablets or phones.
And so this pupil screen device, its program on a phone, can match performance to a pupillometer, which is about $4,500 of medical equipment. This makes it a much better solution to diagnosing concussions than using an MRI scan. And for the limitations of direct observation is that it requires the athlete or patient taking it to be conscious. The pupil screen has to be able to visually see all of their responses to certain stimulus. Now, the other problem is that these tests can last up to 20 minutes, which means that we're not going to be able to go through tons of people very quickly. And also, if the tests are messed up and the data is inconclusive, this process has to be restarted.
The other problem with it is that the variance in how a person normally reacts changes between different people. So different people have different pupil dilation reactions to different forms of light, and you have to have a basis for how the person normally reacts to scientifically discover if there's a change. The last thing we will be talking about is the statistical approach.
And so now statistical approach is essentially using machine learning algorithms with big data. So now example of big data to prove what it actually means. For example, in a study conducted by the University of Vienna, 78 high school athletes were observed, and within that, they basically found 54,247 individual observations. It's a large amount of data which can be fed to machine learning algorithms such that they can train their models.
Now, in this study, they were able to find that there was the symptom frequency of each type. And using this data of headaches being 94% of symptoms, dizziness 75 about, and difficulty concentration 60, they can use this symptom data to diagnose a concussion for that. And then also, Raul et al. From the Changchun Memorial Hospital Foundation used data set of 10,000 trauma patient outcomes to find 25 significant variables, which allow them to find 25 different areas that they can use to define whether someone has a concussion or not. Now, for the benefits of the statistical approach, the data for it is becoming more available. Each new study, the more data is used for the next. Each time this would actually be used on a patient, that data could be used and applied to the next time they want to do it.
So the researchers at Changchun Memorial Hospital were able to train an artificial neural network to discover trends in head injuries, and it was able to determine concussion rates with an accuracy of about 97%, which, if you remember, it's only 10% right now. And this the pupil screen by the researchers at the University of Washington was able to determine an accuracy similar to the $45,000 pupillometers that are used in intensive care units at hospitals.
So now on the limitations of the statistical approach, to begin with, many applications lack sufficient data which is currently available. And this is largely due to ethics in actually harvesting medical data from patients who are not willingly going to give their data over. And to add to that, statistics are only providing really guidelines for diagnosis.
So as you can see on the graph to the right, they can't really, an artificial intelligence cannot adapt to an edge case. As in graph A, the first one, you can see there's one point way above the rest, and there's also, on all of them, there's a few that just fall outside of the general dark area. These are the edge cases that the AI would not be able to understand because it's unable to figure out that these are different than the others. It would not be able to diagnose someone that they had a concussion. Now, in conclusion, we find that the best way of diagnosing concussions is through direct observation.
So according to researchers, to reiterate, 90% of concussions are left undiagnosed. In accordance with this, researchers at Civotech Analysis, which is a medical research association, determined that many high schools were lacking good enough resources to be able to diagnose concussions, and therefore students had to be transported to a hospital and pay medical bills.
And according to Michigan State University, these tests can really be run both quickly and inexpensively as well. And so now that's going to be a huge benefit over MRI machines. So now looking forward, what can we expect? Well, to begin with, typical MRI, CT scans, things of that nature are really going to fall out of favor to machine learning algorithms because their generic models are not going to be as adaptive. And furthermore, they're going to be able to run these tests very frequently on individuals who are having concussions in a high school setting. That concludes our presentation. Thank you.
Okay, thank you. Chandler, tell us about the content of the team presentation and how your research was implemented in terms of your conclusions. How did you implement Ben's research?
So Ben was really looking at the ethics of different machine learning algorithms. And so within that, it was really about getting enough data. And so that's a huge problem which we discussed with this whole approach, is that there's really not enough data present. And so the ethics of how we're going to get that data are going to be significant. For example, in conducting research on a brain interface wheelchair, they really weren't able to achieve enough data to actually get the model to perform properly.
Okay, thank you.
Ben, can you describe an argument from one of your peers' individual reports that made you think differently about your team's solution or conclusion?
In Colton's research by the University of Technology Vienna, by Kai and his associates, he talked about how diagnosis can be used to improve current medical models and like CT scans, which basically went into the statistical approach, but then it developed. We didn't have a statistical approach, but once we learned that we can improve CT scans and MRIs using AI, we started to look at possible research to different symptoms of concussions and how we can use those to help doctors diagnose.
All right, Colton. What is an example of a compelling argument from one of your peers' individual reports that you decided to exclude from your team presentation, and why?
So an argument that we decided to exclude was the argument for taking our current methods of diagnosing them and improving them. Because currently, what our entire research project on is revolutionizing the way we diagnose concussions. But from Raul from the Changzhou University, he said that if we, there's a possibility that if we improve MRI scans and CT scans to be quicker and better, and being able to understand features better, then we can make these even better than the pupil screen that we mentioned in our essay.
Okay, thank you very much.